Alright, we're going to start going through the June 2019 exam, and we are going to start with Part A. Part A is all multiple choice, 30 multiple choice. It is going to basically go through the content in order through the year, starting with atomic theory and then ending with nuclear chemistry. So that's the typical format. So we're going to go through these multiple choice. You should have available your reference tables and a calculator. Although most likely for Part A, which are the easiest multiple choice, you won't need a calculator. But let's see if we do. Which particles are found in the nucleus of an argon atom? You can see we have choices here, right? So this is a good elimination question. So you could see there's protons, electrons, positrons, and neutrons. You should remember that the three subatomic particles we studied are protons, electrons, and neutrons. We did not study positrons as subatomic particles, so anything that has positrons as a choice should be eliminated. Now, what is found in the nucleus? So remember, we have the nucleus of an atom, which contains protons and neutrons, and then around the nucleus we have the electron cloud where you find electrons. So what is found in the nucleus? Protons and neutrons. The diagram below represents a particle traveling through an electric field. Which particle remains undeflected when passing through the electric field? So here we have the particle going down and we have some options. Okay, so let's go through the charges of these particles. A proton is positive. An electron is negative. A positron. What if you forgot a positron or forgot any of these? A good reference table to use is reference table O. What you have to remember is that another name for a beta particle is an electron. And when you look at the bottom number, we're looking for charge. So an electron or beta particle, -1. Neutron, 0. Positron, +1. And you can see proton, 1. It doesn't say +1, but there's a 1 at the bottom. For an electron, it's a -1. So that would be a +1 also. So positron is +1. So which one is going to be undeflected? When we have a proton going through, it's going to be attracted to the negative plate because it has a positive charge. An electron, so that was a proton, as an electron goes through, it's going to be very quickly attracted to the positive plate because it has no mass. A neutron has no charge, so it's a zzz, zzz, zzz. And then a positron, because it's positive, is also going to be attracted to the negative plate. So which one is undeflected? A neutron. The mass of an electron is what? Okay, let's go back to table O. Okay, this can help you. Remember, charge was the bottom number? Well, mass is the top number. So look at the mass of an electron or beta particle is 0. So the mass of an electron, which is 0, is it equal, we're comparing it to protons and neutrons. Let's look at the mass of a proton, 1. The mass of a neutron is 1. Okay, so let's go back here. The mass of an electron, is it equal to the mass of a proton? No. Equal to the mass of a neutron? No. Remember, the electron was 0 and proton and neutron were both 1. So it's going to be less than the mass of a neutron. Compared to the energy of an electron in the second shell of an atom of sulfur, the energy of an electron in the first shell and third shell. So here we have a nucleus with protons and neutrons. Then we have electron cloud, and based on energy level. So we have the first energy level, the second energy level, the third energy level. The closer we are, so this is 1, 2, 3. The closer we are to the nucleus, the lower the energy. So as we move away from the nucleus, the energy gets higher. So the second level has more energy than the first. The third has more energy than the second, and so on. So compared to the energy of an electron in the second shell, the energy of an electron in the first shell is lower. That looks like it's right. Well, would the first shell be the same? No, so we should eliminate those. So if we compare it to the second shell, the energy of the first shell is lower, right? The closer we are to the nucleus, the lower the energy. In the ground state, an atom of which element has 7 valence electrons? So if you don't remember this, well, I just know it, but let's look. So we go to the periodic table and we look at valence electrons. 3. It's the last number in the electron configuration. 4, 5, 6, ding, 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 7. So any of the halogens. So which one do we see? Sodium? No, that's way over here in group 1. Phosphorus? Nope. Nitrogen? Nope. Fluorine? Oh, ding, 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 ding. There we go. Which information is sufficient to differentiate a sample of sodium from a sample of silver? Okay. Can they both have the same mass? Will that allow me to tell the difference between them? No. Can they both have the same volume? Will that allow me to differentiate between them? No. Okay, so now I'm down between these two. So sodium and silver. What phase are they in at room temperature? Well, looking at the periodic table, almost everything is a solid. We have 2 liquids here and here, mercury and bromine. So mercury and bromine. And we have gases, hydrogen, NOF, Cl, and then all the noble gases. Well, we are comparing sodium and silver. Sodium and silver, silver right here, Ag, this is gold, silver, and sodium. Well, they're both solids, so it's not the phase. That means state of matter, solid, liquid, or gas. So it must be the reactivity. And since sodium is in group 1, it is super reactive. In fact, so reactive that it's not even ever found as an element in nature. Graphite and diamond are 2 forms of solid carbon at STP. These forms have, well, you can see we're comparing structures and properties. You should know graphite, that's pencil, lead, that's not really lead, it's graphite, and diamond. Do they have the same properties? Absolutely not. So I'm going to eliminate the 2 that say the same properties. So why do you think they have different properties? Do they have different properties because they have the same structure? Or do they have different properties because, ding, 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 they have different structures? Okay? All right. As the first 5 elements in group 14 are considered in order from top to bottom, there are changes in both the. Okay, so we need to look at group 14. Okay, so we are here. So we could just use the first 3. Okay, that will let us, oh, it says the first 5. Okay, so in group 14, carbon, silicone, germanium, tin, and lead. Okay, so number of valence electrons. We'll compare those, and then let's see the number of first shell electrons. Electronegativity, and then we need atomic radius. Okay, so let's look those up. The number of valence electrons, well, that's easy. That's the same going down. So kind of made a bad table, but make it do. Okay, so like this. The number of first shell electrons, so let's look. 2, 2, 2, 2, 2. Okay, so that does not help me differentiate, right? So there are changes. Are there changes in the valence shell electrons? No. Are there changes in the number of first shell electrons? No. Are there changes in valence shell electrons? No. So in fact, I don't even need to look it up any further. Now I have my answer. So that was easy, right? You just had to start doing it by process of elimination. If we looked them up, you would see that they do in fact change. Where would you look them up? You would go to table S and you would look up electronegativity and atomic radius. But I don't need to do it because I eliminated 3 answers. Okay? Which statement explains why NABR is classified as a compound? Okay. So let's see. What makes something a compound? Well, a compound has 2 or more elements chemically combined and in the same ratio. What does that mean? So if you have water, it's always H2O, 2 hydrogens and 1 oxygen. If you have hydrogen peroxide, it's always H2O2, 2 hydrogens and 2 oxygens. So which statement explains why it's a compound? Because Na and Br are chemically combined in a fixed proportion. That means always 1 Na with 1 Br. So that looks like it's the answer. Let's just double check when we look through. Na and Br are both nonmetals. That is not true. I can show you that at a quick glance on the periodic table. Br is over here in nonmetal. Na, yes, is over here on the metal side. Okay, but they're not both nonmetals. NaBr is a solid at 298 Kelvin and standard pressure. Now that is true, but is that why it's a compound? No. And NaBr dissolves in H2O at 298 Kelvin, which is also true, but is that what makes it a compound? No. So this was false, and these were true, but you had to figure out which one made it a compound, which is this one. Which 2 terms represent types of chemical formulas? Well, let's see. We can have empirical. That's when you reduce it to lowest terms. We can have structural. And we can have molecular. So let's see. There we go. I told you, once you know what they are, that should be an easy question. During all chemical reactions, charge, mass, and energy are, okay, first of all, never decayed. That doesn't even make any sense. They are, you should know this, conserved. Okay, conservation. The degree of polarity of a covalent bond between 2 atoms is determined by calculating the difference in their what? Do you remember? There's like a scale. When if you get a difference of 0, it's nonpolar. When it gets to about 0.5, it switches to polar. Above 1.7, it tends to be ionic, but it's kind of a gradient. Do you know what values you're subtracting to get this? It's electronegativities. Which substance cannot be broken down by a chemical change? That means I'm looking for an element. If you forgot what's an element, I hope not, but in case you did, if you forgot what's an element, start going through this list. Table S. All of these are elements. It's got to be on that list. When you go through that, you should find magnesium. The rest are compounds. Which statement describes the components of a mixture? Okay, so like if you took salt and water, okay, or if you took lettuce and a dressing. Both of those are mixtures. Each component gains new properties. No. Each component loses its original properties. No, you just get salty water. You just get lettuce with dressing on it. Okay? The dressing doesn't become something new with new properties. Okay? Or losing its original properties. So we're down to these 2 options. Either the proportions of components can vary, or the proportions of components cannot vary. It's this one, can. When they cannot vary, that would be a compound. Okay? Table sugar can be separated from a mixture of table sugar and sand at STP by. So I have a pile of something and it is sand and sugar. So what can I do? Well, I can take a beaker of water, put the sand and sugar in here, what will happen? The sugar will dissolve, the sand will not, okay? Then I'll be able to filter out the sand. All right, so what do I need to do? Let's see, in order. Table sugar can be separated from a mixture of table sugar and sand at STP by adding, first what did I want to add? Water. So I don't want to add sand first. Like literally sand is already in the mixture. Why would I want to add sand? So I want to add water. I want to stir it. Now what makes the most sense? Well, I want to filter it. That's going to get rid of the sand. Distilling is to separate liquids. This is not separating liquids. Which statement describes the properties of an ideal gas based on the kinetic molecular theory? So the particles, according to an ideal gas, are very far apart. There are no intermolecular forces. They're moving in constant, rapid, straight line motion. So are the particles closely packed? No. Do they have strong attraction between the particles? No. So now I'm down to 50-50. Are the particles separated by small distances relative to their size? The volume of the particles is considered negligible. Negligible means, you have to know this word, very small. So the volume of the particles is considered negligible. If this were true, it would have to say great distances instead of small. But by saying small, it's wrong. During which two processes does a substance release energy? Okay, so we draw this solid, liquid, gas. This way is endo, gaining energy. This way is exo, releasing energy. So freezing, liquid to solid. That is true. Condensation, gas to liquid. That is, so obviously the rest are going to be wrong. I found it on the first one. Evaporation and melting. So evaporation this way, melting is this way. Okay, so they both have to be moving in the same direction. Okay. Based on table I, so guess what you better do? You better turn to table I. Which substance dissolves in water by an exothermic process? So I go to table. Down here are the dissolving ones. So I can skip all this at the top. I'm only looking down here at the dissolving ones. So I need NaCl. That has a plus sign. NaOH has a negative sign. NH4Cl has a plus sign. And NH4NO3 has a plus sign. So exothermic, if you remember the rules, one of these things is not like the others. Also down here it says a minus sign indicates an exothermic reaction. At STP, which property of a molecular substance is determined by the arrangement of its molecules? Okay, so how the molecules are arranged, for example, like this versus like this, right? Its physical state, whether it's a solid, a liquid, or a gas. Equilibrium can be reached by what? Equilibrium, what does it require? A closed container, a forward and a reverse reaction, right? It has to be dynamic. Can you reverse a nuclear reaction? No. So it's definitely not nuclear. Is it physical changes only or both physical and chemical? It's both physical and chemical. As long as it's reversible. Which value is defined as the difference between the potential energy of the products and the potential energy of the reactants? So that's using a potential energy diagram. It's this right here, and that is called heat of reaction. All right, we're almost done with these. We're on the last bit here. The effect of a catalyst on a chemical reaction is to provide a new reaction pathway that results in a different what? So let me just draw. Here is a reaction. Here's a reaction with a catalyst. Does it change the potential energy of the products? No. Does it change the potential energy of the reactants? No. It doesn't change the start or the end. Does it change the heat of the reaction? Heat of reaction. Well, that's the difference between those. So if the reactants and products didn't change, that doesn't change. All that changes is the activation energy. So a new path with a lower activation energy. Chemical systems in nature tend to undergo changes toward. Think about it. Would you rather do 50 problems or 10 problems? Probably 10, right? Less energy. So systems favor less energy, so these two are wrong. And think about disorder. Like when you got a pack of M&Ms, if they're all the colors are mixed up, in order to put them in order, it would take energy, right? So nature wants disorder because, quite frankly, it's just exhausting to try to put it back in order. So low energy, high entropy, high disorder. So entropy, remember, is disorder. The atoms of which element bond to one another in chains, rings, and networks. This is the one that is prevalent in organic compounds, carbon. What is the general formula for the homologous series that includes ethene? Reference table question. So look, alkenes, ethene is an alkene, and this is the formula. So I just got to find the right one, which is right here. Okay. When an F atom becomes an F negative ion, the F atom, well, first of all, you should know that when things become ions, the protons never change. The only thing that changes is electrons. So if we have an atom becoming an F negative ion, in order to now have a negative charge, it would have had to gain an electron. It's a nonmetal, it's going to gain an electron. Which substance is an Arrhenius base? This is a reference table question. Where do you go? Right here. We're looking for an Arrhenius base. So we're looking through this list right here. What do we see? This one right here. See it? Okay. In which type of nuclear reaction do two light nuclei combine to produce a heavier nucleus? So two little joined together. That is called fusion. Fission is when a big one splits apart. And these are not even types of nuclear reactions in terms of having two nuclei. Okay. The positron emission and the gamma emission, those are types of decay, but not a type of reaction. Using equal masses of reactants, which statement describes the relative amount of energy released during a chemical reaction and a nuclear reaction? Well, what you should remember is that a nuclear reaction produces a huge amount of energy. Okay. So, do they release equal amounts of energy? No. Okay. Which one releases a huge amount? The nuclear. The nuclear reaction releases more energy. Like a lot more. Like a real lot more. The ratio of the mass of uranium-238 to the mass of Pb-206 can be used too. So what does that mean? That means uranium-238, when it decays, it's a transmutation. It changes into lead-206. Okay? So when I look at the amount of uranium-238 that's there compared to the amount of lead-206 that's there, what can I tell? Well, you have to know the use of a few isotopes. Carbon-14 is used to date things that used to be alive. Iodine-131 is used to diagnose and treat thyroid disorders. Cobalt-60 and technetium-99 are related to cancer. Okay, detection, treatment. So what is uranium-238 for? Well, that is used to date, not go out with, tell how old, rocks and minerals. Okay, so if there is more uranium-238, it's a newer rock. If there's more lead-206, that means it's decayed more, so it's older. So which one has to do with rocks and minerals? Right here, geological formations. So thyroid disorders would be iodine-131. A date one, not once living things, is carbon-14, and this one we didn't really have to know. And there we go. That is the end of question 30. We finished part A.